Hello and welcome to another drive-by code session. This is part 2 of the series where WaiKit built a UI toolkit / framework. Let me catch up to what he did in part 1. So this is what he made in part 1, but in more detail, what he made was a label class which can render some text on the canvas, and the label class looks like this, all of about 15 lines of code. As you can see, it uses the canvas rendering context to draw some text. This code here is sort of like some quick and dirty code that he sketched out, and it is meant to be later housed in another UI component, which would be either like a container component of sorts. So the idea would be, following the lead of a lot of user interface frameworks, so the idea would be you have a container, a UI container of some sort. So I'll call this UI container. This might go under a different name as the code gets going, but within the container you could have individual UI elements, one or more. In this case, in our limited example, we might want to put a label in here, maybe even 2 labels. But we could also put something like text fields in here. In fact, you could even put another UI container in here, so it can be recursive in nature, which may have additional stuff within it. So that's the idea. So far, we have this label component, which works. As you can see, it renders the text. This yellow box here, that's simply generated by this code here. So the yellow box is meant to be the area within which a UI container governs. Okay, so that's what WaiKit is going for. So let's see how he does this. The first thing he does is create a vertical layout panel. So this is basically the UI container element that we alluded to. He decided to start out with a simple container, which is a vertical panel. And just like a label, a vertical layout panel also has a render method. And it will have some children. So because this is a UI container element, it'll have some children, but he hasn't decided on what to type the children yet, because he needs to define a type. He is thinking about the name. He ultimately decides on the name UI elements. So and in a sense, or not in a sense, but literally, a UI element, a label is a UI element, and a vertical layout panel is also a UI element. So anything you've seen in the box diagram, each of the things, whether it's the parent container or a child element, all of them are UI elements. And UI elements need to be able to render themselves when given a canvas rendering context 2D. So this here, he made it more explicit that the return type of this render method is void, meaning that it doesn't have a return value. So now that given the type has been defined, we can use the type in the definition of children. One thing about types in Typescript, so this is a Typescript specific feature, so I want to give you a brief explanation for those of you who are not experienced with TypeScript. So this type definition is merely defining the shape that an object ought to be. For example, I could define a type, maybe like a point. I can say a point has to have an x and a y, both of which are numbers. And then if I define this type and later on I want to enforce that a certain variable adheres to that type, let's say my point, I want to enforce that this constant, my point, has the same shape as the shape I defined here. All I have to do is declare that it's type B point using this colon notation. And then TypeScript will check for you, do the type checking for you to ensure that whatever gets assigned to this const must adhere to that type. So if I try to assign it a number, TypeScript will complain. So whatever you try to assign to it must adhere to that object shape. Okay, so this is a very simple type, but a more complex type may include methods. So in order for an object or a thing to be a UI element, it had better contain the method render, and you can either implement this render method inside of an object literal like so. I'm gonna say maybe my element this time, my UI element. So let's say I had a object literal, and if it defines this render method, then it's good to go. TypeScript considers whatever this guy is to be a valid UI element. And if we wanted to validate that, all we do is slap this guy as a label on a variable definition. So in this case, we could, I think, validly do that to label. So given that TypeScript is not complaining, it means label does satisfy the requirements of UI element here. Okay, let's continue. Okay, so he's defining this vertical layout panel. It will have some children, which are all UI elements. And the idea is that the render method, as you will see later, the render method of this panel will go through each of his children and in turn call their render methods. The label class or object used to have these width and height properties, which were really never used. He just deletes them, so those were crufty code that needed to be replaced. Now he wants to move them up to the UI element. So he wants to include this because there will be a phase of negotiation of the sizes. So for example, if the container element, say the container element's children are 2 text labels, and the text labels may want to be of a certain size. So the container element is going to ask its children. So let's say this is child 1. And then maybe child 2 is this size, or wants to be this size. And let's say a benevolent container element would ask its children for their desired sizes and then determine what its own size ought to be. So this will be the container. A benevolent container will ask each of its children for their respective sizes, and then it will decide that it should have a proper size to house all of its children. Okay, so the idea is that there's a way for each child to communicate their desired sizes to their parent. Thus, we're going to define the width and height on a UI element, and this does require that a label have the width and height properties now, although he just deleted them. Okay, so now that there's like this shell of a vertical layout panel, although it's not been fully implemented, WaiKit creates a new instance of it called it panel, and it's gonna push the pre-existing label onto its children array. But there's a TypeScript error saying because the children, each element of the children array must be a UI element, and currently the label type does not adhere to the requirements of UI element. It's saying argument of type label is not assignable to the parameter of type UI element because the label object is missing the following properties from the type UI element, namely width and height. So it's saying basically that UI element requires the existence of width and height, which label does not have. So the next step is to add them. So WaiKit wants to make this a computed property using the getter, which in TypeScript and also in the latest version of ECMAScript, that's declared using this get operator and then a syntax like this. So this becomes a computed property of the object. However, TypeScript is complaining that assessors are this getter. They're called assessor. They're only available when you're targeting ECMAScript 5 and higher, because there's a property in ECMAScript 5 called object.defineProperty, I think. Yeah, if you want to know more about the underlying details of how this works, you might want to Google that. So this is only available when you're targeting ECMAScript 5 or higher. Okay. So he changes the TypeScript compilation option to target ECMAScript 5 or higher. And now TypeScript is happy. We need width and height, both of those properties, in order for label to adhere to the requirements of a UI element. How do you now for width? You determine the width of some text. This is an ability that the Canvas API gives you. You can, if you have a string list.text, you can ask the Canvas context based on its current font choice, including the font family and like weight option and font size. It can measure for you what is the width of this text if it were to be rendered on the canvas. So this is a convenient way to get the width of some text you want to render. For height, what you want to do is to the height is of some text is basically the same as the font size of the height. Now the font size of the font, that's what I meant, font size of the font size. The font size has been sort of hidden away inside this string literal here. So WaiKit is going to extract it out like so, and then he also wants to put this state, this context specific state within this width calculation procedure, although we'll have some problems with this approach, as you'll see later. But anyway, he basically wants to isolate this code within get width so that the result of the calculation is invariant to what the font state of the rendering context is here. And then we'll will also, just in case, he's gonna like revert this font to whatever it was before coming into here. And then now that this font size has been extracted, it can be read for this height property. Okay. So next, I think with that last change before this change, WaiKit has given the label a width and a height, which means it should satisfy the requirements of what a UI element needs to be, and that has eliminated this error. So you can also see that if I try to assign label to a UI element, Typescript is happy now. Next, we also want to make a vertical layout panel adhere to the requirements of UI element also. So that would mean also adding the width and height properties to it. He first adds them to the as public variables of the class. Then he decides to use this shorthand instead. So this shorthand is a TypeScript shorthand, which basically says that these are simultaneously parameters of the constructor and public access variables of the object. So this is actually, to give you a comparison, this piece of code is equivalent to having these guys up here, and then also inside the constructor setting these named properties to the same named parameters of the constructor. So this is simply a shorthand to do the former. So now the vertical panel is going to receive the width and height as parameters to the constructor now. All right, let's see. So at this point we still have the exact same rendering, but the idea is we're going to transfer some of the responsibility, actually all of the responsibility of this surrounding code to this render method. Okay. So for now, changing the parameters here doesn't do anything because we haven't made use of these values yet. All right. So the first thing we want to do, but the big picture first. The big picture is the vertical layout panel will draw itself, whatever that means. It might mean a border, but it will also draw each of his children. So it will loop through each of his children. This rectangle and then clip, these two statements are meant for its children, so that it restricts the drawing bounds of its children. So if you specify a rectangle to clip, let's say it's this rectangle you're going to clip, and then you draw something, anything like hello world, the parts that go extend beyond the bounds of the rectangle will not have an effect. So these guys actually don't even show up. You only get to see the drawn elements within the box. So the idea is the panel will use this clip trick and then ask its children to render, and then that will kind of force the behavior that its children cannot draw outside of its own bounds. And we want this rectangle to be based on the dimensions of the panel. And the previous problem of this this label using a global variable, the context, it was actually this global variable here. We're gonna try to fix that. So WaiKit uses this trick, which is to move all of this code inside of a main method, which immediately makes all of these variables local variables instead of global variables, which will have the effect of invalidating this code that uses this context variable, because context is no longer defined within the scope. So this needs to be fixed somehow. How to fix it? Oh, let's worry about that later. First, we'll set up the routine, the algorithm for rendering each children. So we'll start plotting each child starting from the top left corner. So it'll be like this. Let's say this is the container, or I should say vertical layout panel. So this is vertical layout panel, and this is the width of the panel, and this is the height of the panel. The strategy is that we'll start from the top left corner of the panel, which is 0, 0. And then we will go through each child and ask the child to render itself starting from here. We'll also ask the child to state its width and height, actually. Actually, let me try that. So it's going to ask its child to calculate its own width and height. So if it says it's over here, then it'll draw it and then increment this drawing point to here, so that the next child will be drawn here. And maybe the next child is this tall, and then after this is done, it'll increment the position to here, so that the next child after that is drawn here, and so forth. So that's the basic idea here. So this is the x, y here. So, oops. And we're gonna do this rectangle clipping thing, starting at the whatever is the current x and y coordinate. And then this for loop, WaiKit uses this for of syntax, which is a new-ish feature of ECMAScript and TypeScript. And then he asks the current child to render, given the graphical context. And then this is where this bump happens. After the child renders itself, we're gonna assume the child has a height. Actually, currently it won't just yet, and that will need to be fixed. But after the child renders and knows what its height is, the child communicates its height back to the vertical layout panel, and then the vertical layout panel increases this offset by the same amount as the height of the child here. So this is the height of the child. I'll see, height C for height of the child, and then that's the amount that y will increase to make this bump here. Okay, so now and also I think just in case he saves the context here and restores it for the render of each label itself, so that this change in the font setting doesn't spill out to other areas of the application. So he comments out this quick and dirty code because to basically test out this render functionality of the panel. And now he writes he makes a call to panel.render now, but there's still this stuff that needs to be fixed. This global variable situation, it needs to be fixed. So how does he do it? So notice though, the label currently this width, in order to calculate the width of a label, the label needs a context object, but it doesn't readily have that right now. The render method has access to it, but we kind of don't want the render method to have the responsibility of calculating the width. It's a little weird. So WaiKit decides that a cleaner way to do that is by having a separate method called layout. You can think about it as phases. So a UI element has two phases. First, it will lay itself out to figure out what size it needs to be, and then it'll render itself. And actually, that is true of the entire graph of UI elements. The entire graph of UI elements will lay out themselves, and then they will render themselves. So now I've added a new requirement to a UI element, what a UI element needs to be, and then so we'll tell each child to lay itself out. Although this will, at some point, this line will be moved out actually into a layout method of the panel itself. But for now, this is a quick and dirty solution. We'll tell the child to lay itself out so that it knows what its width and height are. And then I will ask it to render itself immediately. Okay, so now because the width will only be set after the label has been laid out, we need a width property that can be set instead of a computed property. Although not height, so he deletes height. So now label's going to get a layout method, which basically performs the calculation that used to be in this width getter here. And instead of calculating and storing it a constant and returning it, it now sets the result of the measurement to the width property that was just defined. And now this computed width gets removed, and so this calculation is complete. So now what happens is the panel is going to ask the label the panel is going to ask the label to lay itself out, which is going to cause it to receive a width, which in turn this, and height for that matter. No, the height it will always have, I guess. But after it has its own dimensions, we'll use its height to increment the y property, or the y variable. So now this code works and we just see hello world, but that's not the true power of the panel. The true power of the panel is well, before we get to the true power of the panel, we'll draw a little yellow box around the panel to see where it is. So that is the bounds of the panel, which was determined by the dimensions that were initialized when it was created. Just changed it to 300, so now it's a shorter panel. But now the true power of the panel is that it can contain more than one label. Okay, so there it is, 2 labels. Let's see what happens. Ooh, not quite right. The labels are overlapping, so WaiKit needs to debug this. And so there's need to be some additional code here in the render method of the panel. In particular, the translate. This save, I don't know why it has a 0 here. I think that needs to go. This translate, remember, is this trick that when you tell the canvas context to translate, it kind of moves the coordinate system. So whereas the normal coordinate system, let's say, is like 0, 0 to here is 0, 500, and here is 500, 0. If you translate this much, let's say, and it's basically it's the x doesn't move here. The x, at least to my eye, the x is always stays at 0. The y gets increased by the amount of the child's height. So the first child, it'll say translate 0, 0, which would do nothing, and it asks the child to render itself. So the child will gladly render itself maybe here. So maybe this is hello world. And then when the child says, hey, my height is this, and this y gets increased, the next time around, y, let's say this is, I don't know, 20. Next time around, x and y would be 0, 20. So it's going to translate by 0 and then 20, which causes the next child after that to render starting from here. So it'll render here. So that's what the translate trick does, and I don't know what's okay. And then this save and then restore causes it to kind of undo this translation after whenever restore happens. So it'll basically say whatever the state of the context was will restore it back to that point, erasing this translation step here. So this translation is only there for the laying out of and rendering of the child. So let's see. So yeah, that fixes the problem. So now we have child 1 here and child 2 here, and now he just wants to put some more rectangles. So this, he wants a bordered rectangle for the container, and then also draw a rectangle around each of the texts, so you can see exactly where the parent component is, or I should say the container is, and where the children components are. Okay, and okay, lastly, we no longer need that quick and dirty code. Now we have a label component, which can be used to render text, as well as a vertical layout panel, which can be used to stack a number of components. And he also bumped up the font size so they're easier to see. All right, that is the end of this session. I hope you enjoyed it, and I hope to see you next time.